I'm going to flash this illustration up. It is in the book, and I do talk about some examples, some specific examples related to the energy systems and the water systems and the food systems, and how this little illustration, this model of a resilient property is what we've called it, how it illustrates those ideas with some concrete examples. Because again, this idea of thinking in systems is actually quite complicated for many people to grasp.
And this is a household and a property system. So no matter what scale we look at, we're actually living in a system. So systems are real. We simplify systems in our designs and thinking to make them understandable, but just to emphasize, we're actually talking about reality when we're talking about systems.
Perhaps I'll just point out here, a phrase that's quite commonly said in permaculture design is it's not the rooftop or the solar panels or the rain barrel, but it's the ways that these are interconnected that makes all the difference in design. And so in this model, this property, a droplet of water that falls onto the roof wouldn't necessarily be used once. And again, maybe I'll pull back up that pinball machine analogy. I think it's there's some good examples here where if that drop of rain is the pinball going in the top, in the modern day design, that drop of rain is delivered via probably your mains water or your municipal water system. It's used maybe to wash your hands, and then it leaves the house right into the sewer system. But in the model of this resilient property, that droplet of rain is most likely captured on the roof first, stored in some tank. It then might be used for its highest quality use first, so drinking water or kitchen water, and then possibly used for a secondary use, like flushing a toilet. And then quite possibly it might even have a third use, depending on the context of the system and the elements available in that system. Because really a lot of times, nitrogen and phosphorus are just plant nutrients, right? So could we even just reframe what we consider to be pollution and things that we discard as just yields for another system? So for instance, could you use your gray water, and can you use human manure to grow trees or to grow, other biology? So there's one example of some connections on this. This particular home has a greenhouse, and so there is a gray water system shown there.
You've got a rainwater system, but you've also got a treatment train for the rainwater system because the water flows off the roof into the roof gutter system, which discharges via a leaf diverter into your rainwater storages, which produce treatment, and then as you can see, it's supplying through the house, and then that discarded water, where it's discarded, becomes the grey water, and it's supplying the other uses, including the plants. So, and of course, the energy interaction is you've got solar panels there, and maybe even a solar battery, which I've got at my house and works really well. But there are also really interesting interactions between water and energy systems, which some of our researchers discovered. The common rhetoric in Australia is if you use a rainwater harvesting system that might need a pump to supply, that means your energy use would be greater in your household. What we actually found is the opposite. The energy use reduced considerably because most of your appliances in your house actually needs to operate at quite low flow rates and quite low pressures. For instance, like your water efficient washing machine, which I hope you've got, or your low flow toilet, which I think is still a conversation to be had in North America, but we're on the way. They actually react far better with the different supply profile from a a low energy, lower flow rate, um, lower pressure pump than mains water. So, these synergies, these nexus is another word that comes up often, um, between sustainable energy and sustainable water use, and the fact that you can keep using this stuff, grey water, which then becomes plant fibre, which then you eat, or it is reducing heat island effects and making a pleasant environment for you. So what we've described, Michelle, is quite a system, really, haven't we?
Oh yeah, absolutely, absolutely. And your comment about um, the statement or the belief, the false belief that perhaps installing a rainwater system would increase your water usage. I think that's a brilliant example of that previous conversation we were having of using averages, A, using averages and how misleading those can be, and B, not including feedback in, these simplistic projections and calculations on, what we think is going to result from some design element.
Yeah, thanks for raising the water use thing. I was commenting on the water energy nexus and how we often find rainwater reduces the energy use. There's rhetoric mainly in the utility type generated publications, that if you have rainwater in your house, you use more water. But none of our research has ever found that. But we've actually exposed that analysis of whole cities done by utilities where they take the average water use from the entire city. So say take the city of Sydney, for example. 90% of houses have low flow toilet flushing. They have water efficient washing, 40% of houses have water efficient washing machines. 38% of houses have rainwater harvesting, and so on. So there's a whole bunch of things in that average water use that are actually reducing the use from what it might have been. So if you're comparing a house to the average of an entire city, and there's an order of magnitude difference in water use behaviours across all of Sydney, which has got something like 5 million people at the moment. So if you're comparing that average and then saying, how is your rainwater harvesting doing? You've got to compare the average to properties that have no water efficiency. If you're comparing it to an average based on a city with an order of magnitude variation in water use, where so many different people are reducing the water use already, so you're comparing a water saving measure like rainwater to a whole city that's saving water differently, it's not a valid comparison. And perhaps people selling water would like to claim an alternative product increases water demand. So there's that monopoly imperative to protect a source as well. But we're moving on.
All right, there's one last diagram I want to chat about and actually ask you to tell me a little bit more about. And it's one that is based on a research paper that you produced with a colleague. And again, what you're calling systems framework. So if you don't mind, Peter, if you want to just point out.
It is.
Well, it's very much like your real diagram previously, Michelle, but
we probably should have done this one first.
No. This is the local scale concept, because systems has different scales. So this is the property scale. And so if you're in an urban area and you're part of the grid also, so you've got a utility electricity supply, you might have a utility recycled water supply, but not often. You'll certainly have a utility mains water supply. So they're resources coming into your property. What might leave your property and is stormwater runoff, definitely, from your hard surfaces on your property. You're increasing the rate of runoff. Your property might add to renewable energy because you've got solar panels that send some of that locally generated resources to the grid for other people to use. You will certainly be discharging wastewater or sewage, if you like to call it, and there will be whole of systems costs involved in that, and different aspects of human welfare and health outcomes involved in that. But if you go into that side, it's actually a system, isn't it? Where you might have some forestry, some urban forestry going on in there, which is trees and shrubs and grasses, and which is changing the heat island effect of your property, which is providing evapotranspiration, which somewhere becomes rainfall, and rainfall falls on your property and it's affected by wind and solar radiation, and also evaporation, which is different to evapotranspiration. So evapotranspiration is plants transpire water. So water is drawn up from the soil profile into their roots and through their leaves into the atmosphere, where evaporation is water on surfaces that evaporate to the atmosphere. Sitting under your property is a very, very rich ecosystem, which is the soil profile. It's the root zone of your plants. It also stores water to change the runoff effects, different soil types, different characteristics, and you could, which impacts on the stormwater impacts on people downstream and the health of the local waterway. And you could change that by using rain gardens or rainwater harvesting, some infiltration trenches, so gravel trenches. Also, in your site, water infiltrates into those soil processes. And if you can see in that drawing at the dark brown to the lighter colour, water actually can flow at those interfaces from your site within the soil, which is a groundwater process. But if you step up more around the human processes, you could have solar panels. You've got roof runoff from the rainfall that could be stored in rainwater harvesting. You could use wind and sun energy and local battery storage to so you draw from your own energy first with backup from the energy grid. You could have, as Michelle was talking about before, you could recycle your grey water and use it in your garden or elsewhere, and you could use your rainwater harvesting, so your property will be partially off grid and using the utility grid as backup. But there are also in this diagram, apologies, it's complex, but it is a system. There's also, so there are mass balances of energy and behaviour. So there's also the behaviour of the people in that house and on that property that'll be completely different and can be completely different depending on what's going on. But there's also a system of quality going on here, which is quite different to a system and mass balance of energy, water. So, for instance, in the stormwater, nitrogen, phosphorus as total suspended solids, sediments are leaving your property depending on how you manage your soil profile, and they impact on other systems.
Mm-hmm.
So it was necessary to draw that simple diagram that's not so simple anymore, because when we tried to explain to people in this publication and the presentations around it, there are systems within systems, and they are all important, and that everyone's property is actually a system, and you can change a lot of things if you want to, and you can make them better. You can optimize them, which is another key consideration. There it is.
Well, and I'd say not only can you do these kind of things on your property, these local scale solutions in your backyard, but your research is showing that they have tremendous impact and they're important. And correct me if I'm wrong, these local scale solutions are more effective than the many of the alternatives currently being used and considered.
And preferred. Yes.
And preferred.
Yes, because local scale solutions like this, there's a tendency to say, oh, I look at one house and one rainwater storage or one solar panel and say it can't possibly make a difference because the demand is so big. But when you think about that, the demand is the sum of all the behaviours of people throughout all the properties. So if every one of those properties makes some of its own energy or use some of its own water, clearly it changes those demands on every property. So the sum of all those demands is completely different. So that sort of simple thinking has not been applied. And so we end up with the traditional idea that, oh, the demand for water for a whole city is really big. It's too big for, say, one rainwater harvesting system to ever make any difference, so it doesn't. So let's not consider it. But that demand for that whole city is made up of the demand behaviours of every single property in that city. So it's the sum of all those. So if a city uses its own water or own energy at each property, the sum of electricity and water demands are dramatically different. Right. And because you're not building large, inflexible, fixed infrastructure to respond to those changing demands, your system is more resilient. So what our research has found is a combination of local solutions plus the more traditional framework of utility infrastructure is better than either local or traditional centralized infrastructure on their own.
Yeah, and that's a key point. I think that's really a really key learning objective that I want to get across to students listening to this course. Yeah.
Very good.
Thank you.
Thank you, Michelle.